You ever open a math book and it feels like you're trying to read a whole different language? Well, in a lot of ways, you are. So today, we're going to demystify that language. We'll follow a student's journey into foundational math, right from day one all the way to the huge ideas it unlocks.
All right, let's kick this off with someone who's right in the thick of it. This is from a Reddit user, Clorzo, getting ready for a new course. You know that feeling, right? You're standing at the bottom of a mountain, textbook in hand, getting ready for the climb. That's our starting point. Let's start the climb right there with them. So, to follow this journey, we've got to start where they start, with the absolute basics. We're going to look at the tools you need for that first part of the climb and see how they prepare you for the view from the top. When you're learning any new language, you have to get the vocabulary and the grammar down. In math, one of the most powerful visual tools we have is the graph. Seriously, you should think of it like a map for a function. It shows you exactly where you're going and what's happening. And here's a perfect example of one of those maps. This isn't just some generic list. It's a real syllabus from an elementary algebra course. It's the roadmap for the semester. Operations, variables, equations, and then boom, right there in the middle, a crucial landmark, coordinate geometry and graphing a line. This is it. This is the point where all those numbers and symbols actually become a picture. So how do you read this map? It's honestly simpler than you might think. First, you find your input, that's your x value, on the flat horizontal axis. Then you just travel straight up or down until you hit the line of the graph itself. And from that point, you just look straight across to the vertical axis. That's it. That's your output. Input, travel, output. Simple as that. Okay, here's a brilliant little trick for your toolkit. In math, the word function has a really strict rule. For any one input, you can only get one single output. The vertical line test is just a quick visual cheat code to check for that. If you can draw a single vertical line that hits the graph in more than one spot, well, it means one input is giving you multiple outputs. It fails the test. It's not a function. And this shows it perfectly. On the left, you've got a classic sine wave. No matter where you draw a vertical line, you're only ever going to cross that graph once. So it passes. That's a function. Now look at the circle on the right. You can easily draw a vertical line that hits it twice, once at the top and once at the bottom. It fails. A circle is a shape, for sure, but it is not a function. Now, let's look at another foundational tool. This is the unit circle, and you can basically think of it as the Rosetta Stone for trigonometry. It's a perfect translator. It takes any angle you give it and instantly spits out the corresponding x and y coordinates on a graph. It's the magic key that connects geometry and algebra, and it's a total masterpiece of mathematical elegance. So we've got the concepts, we've got graphs, functions, the unit circle, but how do modern students actually practice this stuff and master the language? Because let's be real, the days of just a textbook and a pencil are kind of long gone. Let's jump back to that course syllabus. Look at the grade breakdown. Midterms and finals are obviously important, but notice this. A full 25% of the grade comes from homework and quizzes. That's a huge chunk. It tells you that consistent practice is literally built into the course. So the question is, where does all that work happen today? Well, the answer, more and more, is online. For this course, students use a platform called WebAssign. It's a core part of the Modern Students Toolkit. And as you can see, it's not just a place to submit homework. No way. It's got videos, step-by-step guides, instant feedback. It's basically an interactive training ground for learning the language of math. Okay, so we've seen the starting point, the language of graphs, and the tools used to learn it. Now let's zoom out and see where this whole journey leads. How do these foundational skills, this base camp, prepare you for the summit of advanced mathematics? We start right here, a simple, elegant sine wave. This is our base camp. It represents understanding that basic relationship between an input and an output, and visualizing it on a graph. This is the world of elementary algebra. This is where we learn to draw and interpret these fundamental lines and curves. From that base camp, we start to build. We combine those simple ideas into more complex concepts like linear and polynomial functions. The climb gets a little bit steeper here. And then we take a bigger leap into calculus. Now, a topic like techniques of integration, it looks really complex, and it is. But if you look at what it's really about, it's about finding the area under curves, analyzing rates of change. At its heart, it is still just about understanding the behavior of curves on a graph, the very same skills we started with. And we keep climbing.
all the way to the summit, vector calculus. Now we're in multiple dimensions, describing everything from fluid dynamics to planetary orbits. It's profound stuff, but the core idea of representing relationships visually, of input and output, is exactly the same. The language has gotten way more advanced, but the alphabet is the one we learned back at base camp.
So from a student just prepping for a new course, all the way to the heights of vector calculus, the entire journey is built on one simple, powerful idea that we can turn numbers and symbols into a picture. Every complex idea in math begins with a simple line. So the only question is, what will you build with it?